All of the above.
Okay, so we're gonna pick up right where we left off last class, which is with examples. Okay, solve this by completing the square.
That was an equal sign.
Yes, do it again. Look at the examples we did last class.
I'll have short-term memory loss.
This is math, so if you don't use it, you lose it every time.
We already did that example.
I know. There's a reason I'm doing this one again.
And it's like summer short-term memory loss.
It's like dipping your toe into the water before I throw you in. Mr. Barnes, how would I start this one? Okay. So I move the 29 over, and I get 25 on the right-hand side. Mr. Roberts, what would I do next? Okay, you take your time.
I would say that I'll be here all day.
I feel like I need the Jeopardy theme song to start playing.
Didn't that guy die?
Yes, Alex Trebek died. Broke my heart.
Wait, who? Tom did?
Yeah,
It's like stage 4.
yeah, he had stage 4 pancreatic cancer, I think.
Okay, do you have to just divide -4 by 2?
I do. I have to fill in my C term to make the left side a perfect square trinomial. To do that, I take the -4 and I split it in half, and then I do what with it? What's -4 divided by 2? And then -2 squared? 4. So now I have v squared minus 4v plus 4 equals 25 plus 4, because I have to put it on both sides of the equal sign. The left side will factor into the same number twice. So we'll factor into v minus 2 times v minus 2, which I just write as v minus 2 squared. And then my right side becomes 29. Miss Harden, what do I do next?
I'm really confused right now, so I have no idea.
Okay, so my goal is to get v by itself. What's the first thing I need to get rid of that's attached to my v? The square. How do I get rid of the square? Opposite. Square root. What I do to one side, I have to do to the other. So when I square root a square, they cancel each other out, and I'm just left with v minus 2 equals. Then I have the positive and negative versions of the square root of 29 on the right.
This is the part where
Can I simplify the square root of 29?
No.
No, it's a prime number. Nothing comes out of it, especially not a perfect square. So I just leave it as the square root of 29, which means to finish this, I just add the 2 over from the left-hand side. And I get v equals 2 plus or minus the square root of 29. And then I would put that into curly brackets, separating my 2 terms, and I'm done. Is this starting to ring a bell or look familiar? Yes, ma'am.
V minus 2.
So I looked at this quadratic right here. I look for 2 numbers that multiply together to get 4 and add to get -4. So logically, I know 2 times 2 is 4, and the only way to get -4 is -2 times -2 and -2 plus -2.
Squared it.
Yep.
So what would be like that every time?
It will, because I forced it to be a perfect square trinomial on the left. It will always factor into the same thing twice, which is a factor squared. Every single time. That's the beauty of completing the square. Any other questions? Sometimes, yes. Especially for larger values, this is the easier way to do
Is
it.
that how you write the answer then?
Well, you would do curly brackets, but yes.
Like it's not that bad. I think it's less work than like an actual quadratic formula, just because you have to write more.
Okay, are we ready for another one?
Yeah.
Fantastic. This next example is 10b squared. It's b, but I guess I'll make it b.
10b.
10b squared plus 20b minus 78 equals 2.
That's a lot of b's.
Mr. Bailey, what's my first step?
Add this to the other side.
Absolutely. Add that 78 over, so I only have terms with the variable on the left-hand side. When I do that, I get 10b squared plus 20b equals 80. Then what do I do? The next thing I check for is to see if there's a number in front of my squared term. Is there? I need to divide that value out of every single term in my equation. So I'm going to divide everything by 10. When I do that, I'm left with b squared plus 2b and then equals 8. Now this is a beautiful quadratic that has nothing in front of my squared, which means I can go ahead and complete the square by filling in my c term. How do I find that c term? Half of 2 and then square my answer. What's half of 2? And what's 1 squared? So this becomes b squared plus 2b plus 1 equals 8 plus 1, which is 9. I go ahead and I factor my left-hand side. What multiplies together to get 1 and adds to get 2? 1 and 1, which I'm just going to write as b plus 1 squared, and then equals 9. I think I told you guys this trick yesterday, but I'll tell you again. When I have a perfect square trinomial, the factor that's going to repeat itself is always x plus or minus whatever half of this term was. So here, half of this term, or this term was a positive 2, half of positive 2 is positive 1, and that works every single time. So now I'd like to solve for b. Carly, how would I do that? Solve for b. What am I going to do? Square root both sides. Square root and a square cancel, and I get b plus 1 equals, what's the square root of 9? 3 and plus and minus 3. So 3 and negative 3. It just so happens that 9 is a perfect square, so the square root of it is a whole number.
Okay. Yeah, I think I messed this up pretty bad.
Last step, I move the 1 from the left over to the right, and it becomes b equals negative 1 plus or minus 3, which I will then split into my two expressions. So negative 1 plus 3 is 2. Negative 1 minus 3 is negative 4. So my two answers are negative 4 and 2. Yes, because it was plus, and to move it, I had to subtract it. Questions, concerns, or issues with that? Is this any harder than what we were doing yesterday? No. It's pretty much the same. We just had that extra step of dividing out a common factor. So let's do it again.
Okay. I'm a little bit, I really messed up that first one.
Okay, so here is our shot at redemption.
Just because I completely forgot that we had a variable in front. I just solved it like a regular one.
That would do it. Okay, try this one on your own. Ariana, how do I start this?
Add 77 to the 4.
Okay. Which leaves me with 3x squared minus 18x equals 81. Cole, what next? Okay,
Because I know that I have to factor the two things over there, but I don't find anything that looks like it.
so we can't factor yet because it isn't 3 terms on the left-hand side. So I have to make it be 3 terms by completing the square,
Yeah, so
but I can't do that until there's nothing in front of my x squared term. So what's in front of my x squared right now?
that's very,
So I have to divide that 3 out. And what I do to one thing, I have to do to everything. So once I divide out that 3, I'm left with x squared minus 6x. And then equals, what's 81 divided by 3?
Wait, I divided by 2, how to do that?
You have to. I mean, there's a way around it, but this is the easiest one. So now I have 2 terms on the left with a space for a third, and I have nothing in front of my squared, so I can complete the square. How do I find the c term? Take half of -6, which gives me -3, square the -3 to get 9. So I get x squared minus 6x plus 9 equals 27 plus 9. That will be 36, and I can factor the left-hand side. It'll be -3 and -3, which I will just write as x minus 3 squared, and then equals 36. And then I solve for x just like normal. Square root both sides. What's the square root of 36?
6.
Positive and negative. And then I add the 3 over. And I get 3 plus or minus 6. Split it into my 2 problems, and I get 9 and -3.
Yep. That last one I completely messed up just because I forgot that there was a number in front of the first term, which you have to divide.
Yeah.
And you always have to combine, right? Like you have to combine, like if there's a
The
if,
stuff
like,
on the right-hand side?
Yes.
Yes.
Like if you have to combine something, combine that and then divide and then
Yep.
you'll have them.
Absolutely. It just makes it easier to work with.
Okay.
Questions, concerns, or issues with that one?
If I can do this easier.
Yesterday was easier. It's just one extra step today.
that's why it's a little easier.
Yeah.
Why is that negative?
Okay. Are we okay for the most part with doing these problems?
Why is that -3?
Because 3
Oh,
minus
okay.
6 is
Oh,
-3.
Yeah, no, I forgot.
You're good. So let's do another one. Because I know how much you guys are loving this.
Is this one called anything different?
No, it's still just completing the square.
Then why are we at the other step?
Because there's different types of quadratics that we complete the square with, so we do it in steps. So the first one is a leading coefficient of 1.
It's not
Well, how am I supposed to know if I
This? It's not new, no. If there's a number in front of your x squared, or your v squared, or your v squared, you have to divide.
What is
If
it?
there's nothing there, then you're good to go. All 3.
We didn't do this yesterday.
Could I have done that?
Not the dividing, but we did normal completing the square yesterday.
So if you can combine these and you're supposed to combine them.
Yes, if you can put
Okay,
terms together, you
because
have to put terms together.
I think that I might have messed that up on mine.
Okay. So now I have x squared plus 5x minus 6 equals 0. What's my first step? Everybody.
Add the 6 over.
Add the 6 over.
to the right side.
So x squared plus 5x equals 6. Is there a number in front of my x squared?
No.
No, so I do not have to divide. Which means I can skip directly to completing the square for this c term. How do I find that c term again? I take the term before it, divide it in half, and square it. What's different about this one?
It's a decimal.
Okay, it doesn't divide out evenly, so I'm either left with a decimal or a fraction. We prefer fractions. Okay, so if I can reduce 5 over 2, I should. When I go to square it then, this is the same as the numerator squared over the denominator squared. What's 5 squared? And then 2 squared is 4. So the C value I'm adding in on each side is 25 over 4.
Can we leave them like fractions like that?
Absolutely. Okay. It's only scary because it's a fraction. Otherwise, we wouldn't mind it so much. What I need to do now is I need to go ahead and put that right side together, but I can't do it the way it is right now. Right? Because instead of having something over 4, I have 6 over 1, and I'm trying to add 25 over 4 to that. We can only add fractions if they have the same denominator. So what do I need to multiply 1 by to make it have the same denominator as the other fraction? 4. What I do to the bottom, I also have to do to the top. So I'm going to multiply both the top and the bottom by 4, which turns it into 24 over 4 plus 25 over 4. And then I just put 24 and 25 together to get 49. So now on my right side, I have 49 over 4. And on my left side, I still have this quadratic. Give you guys a second to process that. I had 6 over 1.
Oh, you're on that side, okay.
Yeah, I'm on this side. I haven't touched the left-hand side yet. Yes, we will. Okay. So all I have to do is I have to factor this left-hand side, correct? And I know that every single time it's going to factor into x plus or minus whatever half of this middle term is. What's half of 5? 5 over 2. And I would just leave it as that fraction. So the left side factors into x plus 5 over 2 all squared. So now I have x plus 5 over 2 squared equals 29 over 4. It's just like the previous problem where I need to square root both sides. A square root and a square cancel each other out. And then I take the square root of 49 over 4. When I take the square root of a fraction, that is the same as taking the square root of its numerator over the square root of its denominator. What's the square root of 49? What's the square root of 4? So this square root is 7 over 2, but it's positive and negative.
That is so
What? Oh, I know. So we're going to finish this problem, and I'm going to give you a second to process.
so bad. We gotta take another math class after this.
Depends on what diploma you're going for.
I'm just trying to be out of graduating high school.
Yeah.
That's it.
Then I think technically Algebra 2 could be your last one. I think. That's what I thought. I think you need 3 math credits for a general diploma. Okay, but we are not finished because my x is not by itself. So I still need to subtract this 5 over 2 to the other side, which leaves me with x equals negative 5 over 2 plus and minus 7 over 2. And then I can put it together. Because they are the same denominator, I'm just adding or subtracting the numerators. So negative 5 plus 7 is 2. And 2 over 2 reduces to 1, so 1 is one of my answers. Negative 5 minus 7 is negative 12 over 2, which reduces to negative 6. So my 2 answers are negative 6 and 1. They won't always do.
So if they reduce the fractions and they're like not perfect, just measure, you just leave them as fractions.
Absolutely.
Why else?
How much did we hate that?
A lot.
So much.
You said don't lie to you.
It's
Don't lie to me. I appreciate the honesty. Only lie to me on some things. This is not something I expect you to lie to me about.
I'm so confused.
Okay.
Like, and now I'm like thinking, should I have done the other one like this? And I'm like, I don't.
So what we are going to do, we're gonna do one more for today, and I'm gonna stop because I don't want to fry your brains. Okay? And I want you to try your homework some more. So we're gonna do one more, and we'll finish up the examples tomorrow. Sound good? Because after this, there are only 3 examples left, so it's perfect.
Hooray.
Woo! Okay. Last example for today. Kaylee, what's my first step?
Add the 9 to the other side.
Okay, which leaves me with n squared plus 9n equals 9. Briar, what do I check for next?
You have to add the plus here.
Not yet, I have to check for something first.
Oh, there's not a number in front of the n. So.
Right, so I need to check to see if there's a number in front of my n squared. There isn't, so I don't have to divide anything out, which means I can skip directly to completing the square by adding in my c term. How do I find the c term? What term do I split in half? The 9. So this one right here. So I do 9 divided by 2 and then I square it. Does 9 divided by 2 come out nicely? No. So we're going to leave it as 9 over 2 and we're going to square each of those components. What's 9 squared? 81. What's 2 squared? So I'm adding 81 over 4 on both sides.
I feel like if I had you there to walk me through every single problem.
Just like.
Before I can factor the left-hand side, I need to simplify the right-hand side first. Can I put those two values together the way they are? No, because one's a whole number and one's a fraction over 4. So what I need to do is I need to manipulate this whole number so that it is a fraction over 4. So multiply the top and bottom by 4. Good job, Cole. And that leaves me with what? Okay, so I have 36 over 4 plus 81 over 4, which is 117 over 4.
Does it matter which denominator you multiply by?
Well, I want it to match this one. So it's whatever this is what I multiply by.
Okay.
Every single time. Okay. So let's go ahead and write this. So I have 117 over 4 on the right. What about on the left?
It's gonna be n plus 9 over 2.
Okay, I need to factor it, knowing that it's a perfect square trinomial. It's going to factor into n plus whatever half of this term right here was. That term is 9. Half of 9 is 9 over 2. And then squared. Equals the 117 over 4. Now I have to square root everything. I do that, and I get n plus 9 over 2 equals positive and negative, square root of 117 over square root of 4. Do either of those simplify nicely?
4 does,
The 4 does, it becomes a 2, correct?
but 117
But the 117 doesn't, so I need to look to see if there are any perfect squares I can take out of 117. So I'm gonna do my little factor tree. What can I multiply together to get 117? 3 and 39. We'll start there.
Let's use that one.
3 is prime, 39 is not, so I need to break it down farther. What multiplies together to get 39? 3 and 13. Both of those are prime, so I'm officially done. So my prime factorization for 117 is 3 times 3 times 13. I have a matching pair. I put the 3's together and I get 9 times 13. I don't have any other matching pairs, so I'm going to square root both of these.
Is that really?
And then what's the square root of 9? 3. So the square root of 117 becomes 3 times the square root of 3. So I go ahead and I rewrite this. N plus 9 over 2 equals positive negative 3 root 3 over 2. I'll pause. Last step is to subtract the 9 halves from the left over to the right. And I'm left with 9 equals negative 9 halves plus or minus 3 root 3 over 2. I can't simplify that, right? Because I don't know what 3 root 3 is and I don't want decimals. But they have the same denominator, which means I can put those two values together and it becomes negative 9 plus or minus 3 root 3
How does that become 3?
all over 2.
How does 14 become 3?
Yeah, that's what
That's 13. I'm crazy.
Okay,
It's
I
fine.
was like, how does that work?
I just had 3's going in my brain and that's how it went. 3 root 13. Yes, dear.
Is the first one the one are supposed to be like fractions?
I don't remember what the first one is.
25a squared plus 30a plus 9.
I'll get it explained.
Goodbye. Don't make that face. Oh no, the first one is just a normal practice
No,
problem.
the first
It's a normal factoring.
What is it?
But to get rid of the 25, it's not divisible by.
You're not completing the
Oh.
square. It doesn't say to complete the square, so that's just a perfect square trinomial. It'll factor nicely.
Oh,
Okay. Once you get here, you still have to split it into your 2 answers. 1 addition and 1 subtraction and put it in your curly brackets, but then you are finished. Yeah, so it'd be negative 9 plus 3 root 13 over 2 and negative 9 minus 3 root 13 over 2. Yeah,
Can you just sleep on this or can we use our notes on the test?
I will sleep on it.
I thought we were allowed to.
I give you your cheat sheet. I give you a cheat sheet on the
I
test.
don't know about the cheat sheet.
I might possibly also, I will at least give you a note break, in which case I'll let you look at your notes for a portion of time.
You said that yesterday.
I probably did, because I think somebody asked me. I will think about letting you do open note completely. I doubt it, but I will probably give you a chunk of time where I allow you to look at your notes.
I'm pretty sure I was also the one that asked the question. I'm just not.
And I also say that if you all pass the test, I will throw you a pizza party, so don't forget that.
Okay. So now do I have to go and do that?
You gotta figure it out. Do I have to do that for those?
I don't.
Okay,
Well.
so this is where we're stopping today. There are 3 more examples, but I don't think anything extra new is being thrown at you in those last 3, okay? So we'll finish up those tomorrow, and then we'll be finished with completing the square.
This is all decimals.